Hello everyone, here's our example of a midpoint formula, using it in 3D and also using the distance formula in 3D. So here we go. The example says, find the midpoint and the length of AB when A is this point, 3D ordered triplet, 1, 2, 5, and B is this point, 3, 3, 7. Okay, so we could actually graph this if you want to see kind of what it looks like in 3D, but we don't actually have to either. But if you want it to just visualize it, you could try to graph it in 3D. What's going to happen is you're going to have some point in 3D and then another end point in 3D. One point's going to be point A, one point's going to be point B. It doesn't matter that it's in 3D rather than 2D. That just means it has an extra coordinate, the Z on the Z axis. So that line segment is going to exist in 3D instead of, if my marker is the line segment, instead of in 2D on a 2D paper, for instance, it's in 3D, a 3D space, but it's still a line segment. Okay, it has an endpoint on each end where the ordered triplet is, and we can use these formulas to figure it out. So the midpoint between these two endpoints is going to be the average of the x coordinates, the average of the y coordinates, the average of the z coordinates. All right, so let's do that. Midpoint, M, is going to be x1 plus x2. That will be the x coordinate. The y coordinate will be y1 plus y2. And the z coordinate will be z1 plus z2. So we're taking the average of those. All right, so let's call this first point A. Let's call this x1, y1. The second coordinate is the y coordinate, y1 and z1. Okay, and we'll call this one over here x2, y2, z2. So as long as you have the ones, x, y, z ones all together, x, y, z twos all together, one belongs to one point, one belongs to the other point, you'll be able to do fine. So let's fill this in. We're going to have x1 plus x2 for the x coordinate, y1 plus y2 for the y coordinate, and z1 plus z2 for the z coordinate. Please use proper notation. That ordered triplet needs to have brackets around it. Okay, so this is 4 over 2, 5 over 2, and 12 over 2. Of course, in math, we always want to keep things as simple as possible. Let's simplify it to 5 over 2, 6. Okay, so that's the midpoint of those. Let's find the length of AB. Now, I want to talk a little bit about this notation. This notation means the line segment with endpoints A and B. Okay, that's what that notation means. If we're asking, so we could say find the length of AB. That means find how long it is from A to B. Or we could say find, sometimes you'll see the instructions, find AB. And this also means the exact same thing as find the length of the line segment AB. So this notation, just writing AB, means length of the line segment AB. All right, so let's do that. We're going to use our distance formula, x2 minus x1 all squared, y2 minus y1 all squared, plus z2 minus z1 all squared. That whole thing is square rooted. Let's fill in what we know. So x2, 3, subtract x1, which is 1, all squared. y2, 3 minus 2 all squared. And z2 minus z1 all squared. Now, if some of these numbers are negative numbers, make sure you're showing good substitution so that you don't have pluses and negatives next to each other. You would use a bracket to do that. All right, here we have 2 squared plus 1 squared plus 2 squared, all square rooted, which is 4 plus 1 plus 4, which is the root of 9, which of course is 3. Notice I did not say plus or minus 3 because this is a distance, so we can't have a negative distance. So the only option here is a plus 3, a positive 3. We don't need to write the plus sign though, right? Just keep it as simple as possible. The answer is 3.